Okay, so last video we scaled out. We said need more capacity, just add more servers. So now let us say we have got 50 of them, all identical, all ready to serve. But here is the thing nobody stops to explain. Sitting at your browser, you type in one address, shop.example, one URL. So which of those 50 servers does your browser actually connect to? And it gets sharper. What if the one it picks is the box that just crashed or one that is still booting up? You would get an error, but you don't normally. Somehow, one URL quietly reaches one healthy server again and again. And think about that for a second. The actual machine you land on might be a different one every time you click, and the whole fleet behind that URL shifts from day to day. Same one address, a different server underneath, and you never notice a thing. The thing doing that is a load balancer, and almost every explanation jumps straight into its algorithms, round robin, list connections, all of that. We are going to do the opposite. We are going to understand what a load balancer actually is first, because it is not an algorithm, it is a front door. Let us build it up. So, what is a load balancer? At high level, it is the public front door that sits in front of all your servers. We will draw it as one box, though in the cloud, it is often a managed fleet itself. But the idea is simple. The outside world only ever talks to this front door, and it forwards each request to the one of the servers behind it. That is the whole idea. One front door for a whole building of rooms. And here is the part that is genuinely surprising the first time. Remember when you type shop.example, DNS turns that name into an IP address your browser connects to. Well, normally that IP is not one of your servers. That IP belongs to the load balancer itself. So the public address of your entire app is really just the address of this one front door box. And why does that matter so much? Because the fleet behind the door is always changing. Autoscaling adds boxes when it is busy and removes them when it is quiet. Every deploy replaces old boxes with new ones. Sometimes a box just crashes. So the set of servers is never the same for very long. But from the outside, nothing changes. You see one stable address. The churn, the adding, the dying, the replacing, all of it is hidden behind the one door. And that, honestly, is the load balancer's real job. Not spreading requests, that comes later. Its job is to make a whole changing fleet look like one service. Now, if you are sharp, you are already asking the obvious question. Can DNS just do this itself? Because DNS can hand back more than one IP. You point shop.example at say 3 server IPs and the DNS server just rotates through them. That is a real thing. It is called DNS round robin and it sort of works, but it quietly breaks in 3 ways. And this is exactly why the load balancer exists. 1. Your computer caches the IP. Once DNS hands you server 2, your machine remembers it and keeps using it for minutes until the cache expires. So you are nearly not being spread around. You are stuck on server 2, right? And that is your computer's own DNS cache doing it, not any load balancer. So if server 2 dies in that window, you just keep hitting the dead box and getting errors because nothing is watching to send you somewhere else. And here is the thing, that caching is not even a bug. It is exactly what makes DNS fast and cheap for the whole internet. It is just the wrong tool for steering live traffic to healthy machines. 2. Plain DNS has no idea whether the server is even alive. It will happily keep handing out the address of a box that crashed an hour ago. It cannot check health, so it cannot route around a dead server. 3. You cannot gracefully remove a box. DNS has no notion of stop sending here, and that is not just my opinion. AWS has a smarter DNS feature that even health checks the answers. And in their own documentation, they say plainly it is not a substitute for a load balancer. So, the load balancer is exactly the box that adds the 3 things DNS cannot do: real time health, active failover. It routes around a dead box itself instead of waiting for caches to expire, and graceful removal. So, how does the front door keep from sending you to a dead or half booted box? The answer is health checks. The load balancer is constantly pinging every server behind it. A tiny request that just asks, "Are you okay? Are you okay?" every few seconds. And from that one habit two really important things fall out. The first one is the part most explanations skip. A brand new box does not get any traffic until it has passed a health check. So, when autoscaling spins up a fresh server or a deploy brings new one online, the load balancer holds traffic back as well until that box says, yes, I am actually ready. That is why you never get sent to the server that is still starting up. New boxes have to end their traffic. The second thing is the reverse. If a serving box starts failing those pings, a few in a row, the load balancer takes it out of rotation. And once it notices, your next request just goes to the healthy box instead. You barely notice. This is the self healing we talked about in the stateless video. And this ping and pull itself is the actual machine underneath it. And to remove a box on purpose for a deploy, it does not just yank it, it drains it. Stop sending it new requests, let the in-flight ones finish, then drop it. New box takes over, and ideally nobody's request get cut in half. That, right there, is a big part of how the zero downtime deploy from the last time actually works. Alright, so among the healthy boxes, how does it pick which one? The simplest default is called round robin. Just go down the list, one request to each server in turn. Then loop back to the top. For identical boxes, handling tiny identical requests, that is genuinely fine, right? But, and here is the crack, spreading the number of requests is not the same as spreading the load. One request might be 1 millisecond health check, and next might be a 2-minute job. So, everyone got the same number of requests, can still leave one box drowning while the others sit idle. How a load balancer actually decides, and why round robin is worse than it looks, is a genuinely deep rabbit hole, and it honestly deserves its own video. I made exactly that one. It is linked up there and at the end for today. Just hold this. Round robin is the mental model and just spread it evenly. Turns out to be a surprisingly deep problem the moment request stops being equal. There is a genuinely clever world past this, and that is the whole deeper video. One more term you will bump into, and then we zoom back out. Some load balancers just forward the raw packets fast, but dump. They don't look inside. Others actually read your HTTP request and route on it, like send anything under slash API to these boxes, images to those. That split has a name, layer 4 versus layer 7, and it too lives in that deeper video. Before we wrap, one honest thing, because it matters. A load balancer does not fix everything. It spreads traffic. It does not make slow things fast. If your code is slow, spreading it across 10 boxes just gives you 10 slow boxes, right? And if every one of those boxes is hammering the same database, the load balancer does nothing for that database. That shared database is very likely your next bottleneck. So the load balancer is a router at your front door. It is not a cure. Okay, so a load balancer, the whole thing in three moves. 1. It is a door. One public address hiding a whole fleet. So you type one URL and never think about the servers behind it at all. 2. It only sends traffic to the boxes that are ready. Health checks let the new ones in once they pass and pull the dead ones out, which is the exact thing that makes adding, killing, and deploying servers safe. 3. It picks one box for each request, round robin as the default, and a whole rabbit hole of smarter choices past that. And that is the reframe I want you to walk away with. A load balancer is not an algorithm list, it is the front door. The thing that makes a changing fleet look like a steady service. One address, many servers, traffic only to the ready ones. And here is the funny part, the balancing, the fancy picking it is literally named after, is honestly the last thing to understand about it, not the first. And notice one thing at the very end. The moment that front door starts reading your request, looking at the path, deciding slash API goes here and images go there, maybe even checking who you are, it is not really just balancing anymore, right? It is inspecting and routing. That box has other names, a reverse proxy, a gateway, and often one single box quietly plays all of these roles at once, which is exactly why the name gets so confusing. Pulling them apart is the next video. See you there.